Okay,
If I did it anytime.
so let me kind of paint you the big picture, because yes, it sucks being gone. So, let me kind of get everybody, no pun intended, refocused on what. So, let's start talking about the mirror on the wall. Who's the most stressed of them all? So, start with this idea. What's a simple way that you can tell the difference between a concave and a convex lens? The simplest way to tell between the two of them.
Well, can you walk into it and look far away?
Yes.
Reflected.
So if you can form two different images, one upright, one inverted, that only works when you have a concave lens. Convex lenses only produces upright images on the other side of the mirror, so therefore convex lenses only produce real or virtual images.
Oh, it's mirrors. Real.
Virtual.
Virtual.
That's what
I cannot take light that hits that convex mirror and get spread out and project that onto a screen, okay? Because the light's getting scattered. Now, what you have to remember is that here's your eyeball, okay? So your eyeball is taking in this light, but your eyeball is taking in the light after it has bounced off of that mirror. So your eye is trying to reconstruct like it's seeing it on the other side. Okay, so your eye, what you see, your eyeball is going, oh, it looks like it's on the other side, but it looks like it's much smaller. But because of the fact that with this convex lens, there is no way to like directly measure it because you're not seeing an image, okay, that you can actually measure. You're seeing it, but it isn't something you can measure. So that's the one where you had to do that parallax. So on that one where you have to do that parallax, if all goes well, that distance, and like I said, that's the hardest one for me to explain. Because you gotta like hold your eye and move your head and pat your tummy and all this good stuff. But that distance should be around 14 to 15 centimeters. Okay? Right?
What about 16?
I can live with that.
Okay, yeah, that's fine.
Okay?
Yeah.
Right? But that's why I said it's because of the fact that you're not producing something on a screen that you can actually see. The only way you kind of do it is that parallax. Okay. So you've got on the lens lab, let me kind of give you some hints about where your answer should be. So on that first one on the lens lab on page 2, you have to calculate the focal length. That should be around 20. Okay? I don't have to see every calculation, but you show me one good calculation. Okay? Because you're going to know the image distance, the object distance, from there calculate the focal length. So that focal length should be around 20. Your magnifications, these are absolute values, should range between about 0.2 to about 0.5. Okay? On that one. You've got a ray diagram to draw on number 5. Make sure that you've labeled the focal points, the image, and the object, and the scale. Okay? And I tell you, you draw this for the 80 centimeter distance. I tell you specifically the one that I want. So if that's not clear, you should ask someone. Hand that ray diagram to someone. It's like, can you see what I've got? Can you see the object, the image, the focal point, and everything? If they can't do that, there's no way I am. Okay? So if you're not sure if you've labeled enough, you probably haven't. But again, this is how I start every ray diagram for using a mirror. I've got, in this situation, you've got your object way out here, and then you've got that focal length here. So the first thing I do is I flip this over and go like that. and then make that symmetrical. And then I take that line back like this. So here's the beauty of this. Right away, I have this narrowed down to two potential places. Either that, on that mirror, is either going to be in here, and it's going to be inverted, or it's going to be up there, and it's going to be upright. Okay, those are the only two places an image can appear with a mirror. It's kind of poetic. I didn't mean it that way, but it does. So, let me give you a hint. On this one, what did you all see? Did you see an upright 4 or an inverted 4?
Inverted.
So what does that tell you where that image is? On the left, on this side or that side?
This side.
This side. So that image has to be somewhere here. Because if it was up there, it would be upright. Okay? So with mirrors, you got a 50-50 shot. So basically, if it's inverted, you know it's on the opposite side of, and it's going to be somewhere in that region. Okay. When you get to number 12, let me give you a hint on number 12 when you draw that one. Okay? That, I would start that and put that mirror very close to the left-hand side, because on this one, this is like, again, it's that concave, but you're going to be really, really close. So that's going to produce that image way out there. So on number 12, on the mirror lab, start with the lens close to the left, because that image is going to be far off to the right and upright. Okay? Cool with that? Got it. Good. And then on that last second, number 12, with the convex mirror, and it's the same idea. So here's this convex lens. Boom, you got this. It's going to come in here and bounce off. So you know it's going to be somewhere up there in that region. And with convex mirrors, you don't even have to worry about that option. You know it can only exist up there because you can only produce one type of image. Does that help clarify that? Cool? Okay. Let's talk about the lens lab. So, on page 3, again, you've got to go through and calculate that focal length, okay? Those focal lengths on page 3, question 3, where you're filling out that table, this is an ish, but they should be somewhere around 10 centimeters. Okay? They should be somewhere around 10 centimeters. Your magnification, in terms of absolute value, should go somewhere between 2 to about 0.5. Okay? I'm not saying positive or negative, I'm just saying your magnification should be somewhere between 2 to around 0.5. Okay? Now, the difficult one is this last one on page 4. Okay? So, and if there's one that you have to have it specifically at the dimensions that I tell you to, it's that page 4, question number 2. So you've got that light source here, and you're going to take that convex lens and put that at the 15, you got that 15 centimeter, and that's going to be placed out here at the 45 centimeter mark. So here, be careful about this. Is your object distance going to be 35 or 45? Do not make this difficult. 35, because you're going from 10 out to 35. So be careful when you do that calculation that you realize, oh, that's 35 centimeters away. Now, this concave lenses are tough. They're very useful, don't get me wrong, but they're tough in terms of the ray diagrams, mainly because of the fact that it's going to disperse that light. So because that light is getting dispersed, is your focal length gonna be a positive or negative number? Negative, because that light is getting spread out. So with this one, you should see that image appear kind of almost like a hologram in front of the lens. So that's that, like I tried to show you, like you look over the top and you should see a very small floating 4 right in front of that. So on that ray diagram on number 4, okay, so that light is coming in, it's hitting this, and part of that light is getting refracted. So the image that you're seeing is a refraction of some of that light that's getting sent back. So what you should see on number 4 is that you get a really small image on the left side of the lens. Okay? All right. Any questions? Good? Okay, you've got the rest of the time. Both of these labs are due on Monday. I'm done. So, you need to go get data, go get data.
I'm starting on the left.
And if you need that bulb, that's, did Joel use that yesterday? Okay, all right. Okay, good. Yeah.
That's all.
I have one slight complaint
Huh?
about
That's all I want.
Okay.